And this is the problem why we need the system. The garbage truck always block the traffic, and the worker always have to work in the dirty environment, and the rubbish always overflow and always need the worker to collect the rubbish from time to time. And next, this is a solution that we provide. Eliminate garbage truck by using a network underground pneumatic pipe, and the waste container are solar power sensor and to detect the capacity of container. And there are auto-scheduled pneumatic systems that are working 24/7 without disturbing the neighborhood. And there is airborne antibacterial cleaning system for daily pipe cleaning. And now we're going to demo a video for have your visualization.
Is that audio?
Hold on for what? Okay.
This is Hannah. He works in the waste management sector as a manager. The current waste management system collects rubbish from house to house with a garbage truck, and the garbage truck hosts customers and community. Okay. He thinks that the current waste management system is inefficient, unhygienic, costly, time-consuming, and not good for the environment. There should be a better way to do this. Introducing the SURP management system. A smart underground pneumatic refuse management system. Now, this is a better way to manage our waste. Let's take a look at how SURP can help in solving the concern. When this guy throws rubbish into the rubbish bin, we detect the capacity of it by using a sensor, and the sensor will continuously monitor the capacity until it reaches 80% or more. The solar power sensor will then trigger a schedule for waste collection, and this can eliminate garbage truck on the road and provide a happier, smart city environment. This is SURP.
And so this is a ASR, architecture significant requirement that we consider. Most important is the performance. The attribute requirement, we have throughput, response time, and efficiency. The next is the flexibility, reliability, and availability of our system. Which availability means downtime during maintenance. Our system will have like downtime only 1 hour every 24 hours for maintenance. For maintainability and accessibility and scalability, supportability, and that's the ASR that we consider. Next, I will pass to my friend.
So we actually prepared a little bit of diagram to help us visualize our concept. So this is our conceptual model. And so as you can see, starting from capacity sensor, I forgot to mention we actually use the publish and subscribe architecture style. So starting from capacity sensor, it will first transfer the reading to our cloud, our broker, which is go through my firewall, and then our broker will be actually the one, something like a middleman will be transferring the info to both web server and database, because our web server and database actually subscribe to our capacity sensor, and then there will be web server basically will monitor. Basically, web server will be monitor everything, most of the stuff, and then he will send the command to WAF, which is our container, the waste container, and then it will actually open up the WAF to enable the collection of garbage. And then for our database, anytime our web server need to retrieve any more data, they can refer to our database. So this is our use case diagram, a little bit about our actor. So we have citizen, sensor, waste management, and residential building management. So basically what sensor can do is actually to scan the capacity of waste management, and then to send the threshold of our, to send the threshold alert, and then allowing our waste management center to actually schedule the collection of rubbish. And then our waste management center will be able to monitor capacity of waste container as mentioned just now. And then they can also actually schedule the time for disinfection of our pipe for cleanliness. And then they actually have a complaint system where they can actually receive complaint from both citizen and our residential building management, so they can actually monitor the complaint. And then this is the part where they actually, our citizen and residential building management receive send the complaint, and then our residential building management can also monitor the pneumatic pipe where there's to check if there's a fault or the cleanliness of the pipe, so that they can actually send the complaint, so allowing our waste management center to monitor the complaint. So this is our activity diagram. As the activity diagram will be covering use case about scan capacity and then monitor capacity, send the threshold alert, schedule collection of rubbish, send complaint and monitor complaint. So starting from this, they will be scanning capacity. This I'm not sure you can see, but yeah, sensor will be scanning the capacity and then create a log, and then eventually go through our database. And then our sensor will, after scanning the capacity, they will be also checking the capacity of container. If it's exceeding 80%, and then it will actually send a threshold alert. So eventually it will go to our waste management center again and ask them to do a schedule for collection. And then this is our residential building management and citizen, where they can actually do the same complaint to our waste management center again, so they can actually monitor our stuff. So this is the sequence diagram. We will be covering scan capacity of waste container and then schedule the collection of rubbish. So this is our sensor, the actor. They will be getting the reading, pass reading and filter reading in our sensor component. There's actually quite a few components. It's a subsystem, so it contains a few components inside. So they will be doing the get reading, pass reading and filter reading, and then allowing our broker to pass the pass reading to our SURP management system, where they actually get the pass reading and then to be able to set the schedule. So allowing our broker to actually send the WAF, allowing our WAF to be opened up so that it can run the collection of garbage. So in the end, and also the broker can actually open up so that they can pass the reading to our database. So this is our component diagram as mentioned just now. So basically it's mostly the same. So this is our subsystem for our sensor component. So sensor will be actually scanning, and then parser will be doing the passing, and then filter will be filtering the reading of everything so that it actually doesn't get fluctuated data. And then this is our SURP management system subsystem, where they can actually monitor complaints, schedule collection, and do schedule disinfection. The rest is actually the same. So this is our deployment diagram, as a little bit similar to our conceptual diagram, where this is our capacity sensor. We will be go through all this stuff as I mentioned, all of this. And then this is our artifact. We will be using cloud MQTT, which is one of the MQTT. And then we'll have SURP wall, and then this is our database artifact. So allow my friend to actually continue. Thank you.
So we have mentioned earlier about why about us using publish and subscribe and also MQTT. So why do we actually use publish and subscribe? Because we are actually, this is actually kind of an IoT rubbish bin. So publish subscribe because it is fast, it is real time, and it's also independently scalable because both sides doesn't really need to know about each other. They are pretty much decoupled. So and also MQTT because it is very lightweight and reliable messaging, because MQTT is actually considered relatively reliable with a few levels of they call it a QoS, quality of service, which is there's 0, 1 and 2. So maybe the quality of service of doing 0, which is fire and forget, and 1 and 2, which is at least once, and also a few different 3 types of type of messaging. So for the elements of architecture, the few components is definitely publisher, subscriber, broker, our firewall, and also the database. So the publisher can connect to the subscriber through a broker, and also the topology is the publisher can post message to the broker, and subscriber can subscribe to topics, so they can customize to what they actually want to know. And also the properties of it is the publisher don't need to know anything about the subscriber, and also the subscriber is they can express interest in many different type of things, which means they can subscribe to anything that they like. So moving on, I'll just demo a little bit about what it's going to be like. So over here we are actually using a virtual sensor. And it's going to be connected to our cloud MQTT, which I mentioned earlier. This will be acting as our broker. Then I'll be using this as our client. So it will be something like the dashboard of our SURP management system. So I've created a sensor which will simulate the data that will be passed to our broker. So it will be simulated as an increment of the scanning capacity will be an increment of 10. So let's see. So over here I'll be subscribing to the capacity, and also I'll be subscribing to we start our device, then it will be going through to our broker, and then is the connection. Okay, so maybe that one is not really. So anyway, another view of it, because of the cloud MQTT, they actually provide another way of viewing, which is called the web socket as well. So as you can see over here, so let me restart this. So just one more minute. So as you can see, we will actually simulate the capacity of 10, 20, then 30. So as we mentioned earlier in all of our diagrams, we'll actually send an alert message when it reaches 80%. So when now it reaches 80%, we'll actually have another alert for the, we actually publish another alert message. So because we're using publish and subscribe, so our alert system will actually subscribe to the alert. So when it receives the alert message, then it will actually trigger a schedule for our scheduling to, so I'll stop this first, to actually trigger a scheduling for waste collection, of opening the valve and collecting, sending it to the waste management system. So that's all from us.
So we'll open to the Q&A.
Questions?
Can you go back to your architectures now?
Which one?
The first one. Harrison. So the database you're using is MySQL.
Yes.
So the database stores transactional data, right?
Yeah.
How does the cloud MQTT communicate with the database again?
So database will act as a subscriber to one of the to the data itself as well.
But it's a database. There's no. Is it possible for database to subscribe to a from the topic? I think there should be another layer there, in which that should be a app server that acts as an intermediary between the database and the broker, which is more proper, so that the app will, or the intermediary will, which will write to the database. So it subscribe from the cloud, and then write to the database. Can you go to the first slide? Where all the collection thing. Yeah. Okay, now go. Next. So your solution will eliminate all the garbage truck, right?
Yes.
So you will introduce a pipe whereby it will suck up all the garbage. Yeah. So your solution basically on the software side is just more on the sensor detecting the
Automated collection.
automated collection.
How does the sensor connect to the cloud?
So like just now, it's going through a publish and subscribe. So because our rubbish bin will have a sensor to constantly publishing their capacity. So when it reaches a threshold, then it will actually then it will publish another alert message, and someone will be subscribing to the alert topic. Then it will schedule the collection.
The basic question is, how does the sensor connect to the cloud?
Through just now
Oh,
our
yeah.
cloud MQTT broker.
MQTT.
I think the question is basically
Through which medium? How does this sensor communicates to a server or your cloud infrastructure?
Oh, so you mean like how our sensor will be connected
Yes.
to the net or something like that?
Yes.
So we will most likely be having will most likely it will definitely be connected to some kind of maybe Wi-Fi or something like that, because if we are using this kind of architecture, the sensor itself through MQTT we actually require the main point of it is because it requires very low power, and also the data, the stuff that they send is very the bandwidth is it can be really limited. MQTT is kind of built for that, so that should require a very minimal connection.
in the event of failure. I mean, say if one of the sensor dies or something. So, is there any trigger?
So,
Is there any system that pings, like for example, pings the sensor for reply or anything?
as of yet, we have not figured. We haven't go into that side. But then we have another method which is crowd-based, which is the end user itself will actually send a message.
Send a reply.
So we have a QR code for each unique rubbish bin. Yeah.
To scan the QR code.
In your ASR, one architecture significant requirements, one of these requirements is about performance issues. So how in your design that you address these performance issues in your design solutions? In which way you basically addressing these performance issues?
So maybe like for the response time, just now like in my publish and subscribe, my sensor actually configure it to publish every 3 seconds. So it actually ping every 3 seconds.
Is there any performance strategy, in design strategy that you have taken into consideration to achieve this performance, beside ensuring that using the right protocol?
Because the protocol that we use is MQTT, and this is a lightweight protocol messaging, so we assume it is quite fast, the fastest that we choose.
True, but beside in terms of the protocol, looking into the design issues of communication protocols, in any of the design strategy that you consider to achieve this performance, and you have what? Can you go to the next slide? For example, reliability. How do you ensure the accuracy? How do you ensure the availability? How in your architectural design, because you derive from this perspective, you have logical aspects, you have physical aspects. So is in any of your design actually addressing this ASR?
So like for flexibility, so because we are actually just alerting. Even though it's kind of automated, but it's not fully, because we still have these choices to actually make the scheduling, because we're only sending an alert for like, hey, this bin is at 80%. You should start scheduling. You should start taking concern about it. So that is for the scheduling part. Then accuracy.
How about availability? To ensure that the system is able to have only 1 hour downtime within 24 hours. So how do you put address? How do you map this in your design, or how your design will address this?
For this part, actually our 1 hour every day is for maintaining plus updating, plus disinfecting, cleaning of our pipes. So apart from all of our cleaning, we don't actually expect any other too much of a downtime. So this one we are taking into consideration of our cleaning and also all of our so-called daily routine maintenance to prevent like big kind of sudden thing from happening.
Things we move on to the other because we have time already. But I think you please consider doing design solutions, design architecture design against all these ASR, which is only a partial part of it has been mentioned.